Hello, in this video let's look at the double angle formulas. So sometimes we run into these when we have to prove identities, and this means that there are more than one formula for each of these situations. So for the sine of 2 angle, so it could be sine of 60, so 2 times 30, or sine of 90, 2 times 45, or whatever else. So that equals to either 2 times sine A cosine A, or we could also use a different formula, which is 2 tangent A divided by 1 plus tangent squared A. So the first formula and the second formula have multiple choices, and depending on our situation, we will pick one of these choices that would best fit. For the tangent double angle, there is only one formula. And so just for ourselves, let's prove that the tangent of 2a, the 2 tangent a plus 1 divided by 1 plus tangent squared is actually equal to 2 times sine a cosine a. So we'll verify this identity right now just for practice. So here we go. Let's write the identity next to each other and see if we can convince ourselves whether it is true or false. So the identity is 2 sine a times cosine a. Is it equal to 2 times tangent a divided by 1 plus tangent squared a? So to compare, it may be easier to convert both tangents into sines and cosines, because it is much more complex to go from sines into tangents than it is from tangents into sines. The tangent is sine over cosine, so we can replace each tangent with sine A divided by cosine A. And here divided by 1 plus tangent, which is once again sine squared, divided by cosine squared. Now at this point, we see that we have cosine on the bottom of each fraction. And in fact, if we look here on the top, we have cosine once, here we have cosine twice. If we multiply top and bottom by cosine squared, then both cosines will be eliminated. So let's do that. Let's multiply the top by cosine squared a and all of the bottom by cosine squared a. We can do that because we are multiplying top and bottom, and that means we can always cancel back and make it equal to 1. So here, 1 cosine cancels with a cosine, making the top equals to 2 sine a times cosine a, which is good because that's exactly what we have on the other side. Now, what happens on the bottom here is we have cosine squared times 1, that's cosine squared, and then cosine and cosine cancels off, making just sine squared on the bottom. Now the sine plus cosine squared is one of the Pythagorean identities, and that equals to 1. So our entire denominator is just equal to 1, which means we don't have a denominator. We only have 2 sine plus cosine, which is exactly what we have on the left-hand side, and we have shown the identity is true. And that's it for this video. If you have any questions on anything, please let me know. Here are the identities once again. And that's it. Thanks for your time. Take care.